Okay, today we are going to be talking about how to convert from degrees to another type of angle measurement, which is DMS, and we're also going to learn how to convert from degrees to radians. And these are just different ways to measure an angle. And so the first thing that we want to understand is this DMS stands for degrees, minutes, seconds, and it's just a different way of measuring an angle. The key conversion here is that 1 degree equals 60 minutes. And the way I remember this is there's a TV show that comes on Sunday night and it's called 60 Minutes. And so that's how you keep it straight. 60 minutes is equal to 1 degree. Now these minutes are not necessarily the same way as time is concerned, but it's just a way of measuring the angle. So this is the key conversion. So I'm going to box that in. This is your key conversion that you're going to use for all of these problems. So let's go ahead and get started. We have 37 degrees. So we're going to say, okay, 37 degrees. Actually, let me do this, 37 degrees. Now we're going to take the 0.425 degrees and we're going to convert that to minutes by using this conversion factor. So it's going to be 60 minutes. And the key is that you want to have the units that are going to cancel, one on the top and one on the bottom, similar to what you did in chemistry. So that way you have degrees on the bottom, degrees on the top, cancel out, and what you're left with after you multiply that on your calculator is going to be minutes. So it's going to be 25.5 minutes. Now, how many whole minutes do we have? We have 25 whole minutes. So we're going to go ahead and put that right there, 25 minutes. Now, we have 0.5 minutes that we have not accounted for. So we're going to convert that further into seconds. So 0.5 minutes times the conversion factor. 1 minute has 60 seconds. So once again, we have the minutes that cancel out. 60 times 0.5 is 30 seconds. So we have 30 seconds. So then there we have now converted, and by seconds using 2 apostrophes, and there's your final answer. 37 degrees, 25 minutes, and 30 seconds. Okay, now we're going to go backwards, and we are now going to convert from DMS, and we're going to go backwards, and we're going to convert into degrees. Okay, now part B, we want to go backwards. We want to convert from the degrees, minutes, seconds form to degrees. So we have 42 degrees, so we're going to put that over here. We have 42 degrees, and we have 24 minutes. So we need to convert this minutes to degrees, so we're going backwards now. So 24 minutes times, and we're going to use our little trusty conversion factor here. So this time the 60 minutes will be on the bottom, and 1 degree will be on top. And so we're going to cancel our units. And so when we cancel our units, that's going to end up giving us 24 over 60, which is 0.4 degrees. We also have 36 seconds. So we need to convert that to degrees as well. So 36 seconds. And we're going to convert that first to minutes. So 60 seconds. 1 minute, and then times 60 minutes, our trusty conversion factor is 1 degree. So essentially we have 36, so let's cancel our units out. If we cancel our units, seconds goes away, and minutes goes away, and what we are left with is 36 over 3600, which is 0.01 degrees. Now, if we add up 42 degrees plus 0.4 degrees plus 0.01 degrees, we get 42.41 degrees. And essentially, that's all there is to it for converting back and forth from degrees, minutes, seconds to degrees, or degrees to DMS. Okay, now we're going to talk about how to convert angles from degrees to a whole new angle measurement called radians. And if you notice that your calculator has 2 modes, it has degree mode and radians. So we're going to learn how to convert back and forth between the two. Now the first thing we want to understand is what is a radian, okay? A radian is basically this. It is the angle at which the radius of the circle has the same length as the arc of the circle. So when the arc of the circle has the same length as the radius of the circle, that angle is a special angle called a radian, 1 radian. And it happens to be, actually, 1 radian happens to be around 57.3 degrees, but who's counting, all right? So that's the idea. But we're going to define radians in a different way in the next portion of the video. Okay, here we are. We're going to convert from degrees to radians and radians to degrees. And the main conversion, it says to convert from radians to degrees, multiply by 180 degrees over pi radians. And then conversely, if you want to convert from degrees to radians, multiply by pi radians over 180. This is the same idea as converting from feet to inches. Okay, so if you have 12 feet and you're trying to convert that to inches, well, it's the same idea. You would say, well, 1 foot is the same as, 12 inches? And so that way you would have your feet cancel out and you'd have 144 inches. It's the same idea here. All right, so you're just converting units. So the idea, once again, is pi radians is equal to 180 degrees. That's your key trusty conversion. So part A, how many radians are in 90 degrees? So we're going to say 90 degrees, and we're going to multiply by our trusty conversion. So we're going to put degrees on the bottom because we want the units to cancel. And then we're going to put pi radians on the top. And then we're going to cancel our units. Degrees and degrees cancel out. 90 and 180 reduced to 1/2. So this ends up being pi over 2 radians. So now we understand that 90 degrees is the same as pi over 2 radians. Now after a while you'll get very, very quick at this because you'll know, well, if pi radians is 180, then 90 is just half of 180, so 90 must be half of pi over 2. And then you'll say, well, if 60 degrees, let's see, 60 is 1/3 of 180. So therefore, 60 degrees is really pi over 3 because once again, you're thinking of pi now as not 3.14, but as 180. So 180 divided by 3, bingo, gets you 60. And after a while, you'll be able to do these very quickly in your head. So we actually did part B. How many degrees are in pi over 3 radians? Well, the long way would be to do it this way. Pi over 3 radians, this is the long way, times, we're going to put pi radians on the bottom and 180 degrees on the top. And then we're going to cancel off the word radians. We're also going to cancel off the pi's. And that leaves you with 180 divided by 3, which is 60. And the units that are left over are degrees, 60 degrees. But after a while, you'll get faster at this, and you'll be able to say, well, if I think of pi as 180, then 180 divided by 3 is 60. So if I say pi over 6, you'll be able to look at that after a while and say, well, that's just 180 over 6. That's 30 degrees. And converting from degrees to radians and radians to degrees is just that simple. Okay, next we're going to talk about something called arc length. And so we know that the distance around a circle is called the circumference. And the circumference is the distance all the way around the circle. But let's say we only want to go from maybe this point on the circle. Let me see if I can trace it pretty good. All the way over to maybe here. All right, and we want to find what is that length. We don't want the whole thing. That's called arc length. This portion of the circle is called an arc. The length of that is called the arc length. And the letter that we use to represent the arc length is the letter S. So let's go ahead and circle that or put a box around. S is the arc length. Now we have a formula for that. S is equal to the radius of the circle times theta. Now, this formula is for radians. Let me underline that. This formula is if the angle given to you is in radians. Now, this one is if the angle that is given to you is in degrees. So make sure that you're using the right formula for the right problem. Now, let's look at example 3. It says, the perimeter of a pizza slice. Find the perimeter of a 60-degree slice of large pizza. Okay, I'm getting hungry just thinking about this pizza. So I'm going to draw a pizza. Okay, and there it is. That's about good. And then I'm going to draw the crust. So there we have it. All right, so the angle here is 60 degrees. That's my angle. And the radius is 7. So there's 7 and there's 7. All right, so we want to find the perimeter of this piece. So that means we need to find the arc length. Now, the angle given to us is in degrees. So we need to use this formula here, or we could convert 60 degrees into radians and then use this formula right here. Either way, we need to use one of these formulas. So S equals pi times the radius, which is 7, times the angle theta, which is 60, divided by 180. All right, so 60 divided by 180 is the same as 1/3. So we're going to go ahead and just cancel those out, and we can put 1/3 in its place. So that's going to end up being 1/3. So this is going to be 7 pi over 3. All right, so 7 pi over 3. And that's just going to be just the length of this part. And many people will put this answer down, not realizing that this is actually, the perimeter is the sum of all the sides. So this side, and this. So that's going to be 7 plus 7 plus 7 pi over 3. And as a decimal, that's going to be approximately 1.33. And because it is perimeter, we'll put some units on there, inches, and essentially that's all there is to using the arc length formula. Okay, for this last problem, we are going to convert from, it says here, Albert Juarez's truck has wheels that are 36 inches in diameter. And so let's go ahead and draw that out here. We have a wheel, all right, and the diameter is, see here, we'll draw that diameter. The diameter is 36 inches. So 36 inches is your diameter. If the wheels are rotating at 630 revolutions per minute, find the truck's speed in miles per hour. Okay, so always start with what they give you. 630 revolutions per minute, that is speed. We want to convert that to a different way of measuring speed, miles per hour. So let's write it out. 630 revolutions per minute. And I highly recommend you don't write RPM because that doesn't mean anything. You need to know which units are on the top and which units are on the bottom. So revolutions per minute. So we need to convert that to miles per hour. So at the end of all of this process, we need to have miles as the only units on the top and hours on the bottom. Well, let's go ahead and convert time first. That's pretty simple. All right, we know how many minutes are in an hour. So 60 minutes is in 1 hour. So that's pretty easy. All right, and we have hours on the bottom. So far we're good. Now here's the tricky part, revolution. Now, 1 revolution of the wheel is the same as what? Oh, the circumference of the wheel. 1 revolution is the circumference. And what do we remember from earlier classes? Circumference is equal to 2 pi r, or pi times the diameter. So we're going to say 1 revolution is the same as 1 time around the circle. So that's going to be 36, which is my diameter, pi, and give me some units, inches. All right, inches. Now we've got to convert that to miles. So we first have to go through feet. So there's going to be 12 inches in 1 foot. And then we have to remember that there are 5,280 feet in 1 mile. All right, now let's see if we've done this correctly. Let's see if our units are going to cancel out. Minutes, gone. Revolutions, gone. Inches, gone. Feet, gone. What's left on the top? Miles. What's left on the bottom? Hours. That's what we want. You multiply all of this out and you will get 67.47 miles per hour. Now make sure that your answer that you write down is a reasonable answer. It actually makes logical sense. If you get an answer of 672 miles per hour for a truck, you've done something drastically wrong.